Ladies and gentlemen, welcome to the continuation of these lecture series relating to pharmaceutical compounding, the basics. So today we are looking at the first part of key formulation skills, and we look at weights and measures. So in terms of introductory to these concepts, this topic covers fundamental skills required to accurately formulate. Okay, so in order for us to be able to accurately formulate, we need to have skills in how we weigh, how we use balances, how we also apply techniques in measuring liquids, as well as other related components of formulations. It will also cover skills relating to mastering conversions, how we can convert different units of measure from the larger ones to the smaller ones in reduction, or from the smaller ones into the larger ones for precision purposes. Weighing fundamentals includes the use of units. So in terms of units used in pharmacy, we use the standard international system based on grams. In terms of weight, we use grams, and the subunits of grams are milligrams, micrograms. We also have nanograms and the rest, but mostly we are using milligrams and micrograms. It is important for small weights to be written in full. For example, micrograms, nanograms have to be written in full because the micro sign may actually be misinterpreted for milligram, and that can cause patient safety risks, and as a result of the issues of poor dosing and dosing errors. The common units and their equivalents enable precision, and so this is crucial in weighing pharmaceutical substances. So what are the types of balances we have? There are a number of them. The main ones are three. We have class 2, dispensing beam balances. Obviously, these are balanced with the metals and then with the substances that we are weighing. And so they are suitable for 100 milligrams to 25 milligrams within 10 milligram incrementals. And then we have those that are sensitive, analytical, electronic balances with accuracies of 1 to 1 milligram for weights below 150 milligrams. Then for larger materials or bulk materials needed in the formulation, we use large balances that weigh above 50 grams. So these, you have to be familiar with them as you enter the compounding labs so that you can help in choosing the right balance to ensure that accuracy in measuring ingredients is maintained. In terms of weighing techniques, some highlights to remind you, this is important that proper setup of beam balances is done, including leveling of the instruments and ensuring that your environment is clean, the balances are clean, and the pointers are properly centered. Now, weights are placed in the metal pan, which are balanced with the material that you are weighing on a different class pan. Then you do not use your fingers, your hands to pick the material that you are weighing. You have to use instrumentation that can assure that there is no contamination. You need to check your weights twice, more than once. This is important to ensure that accuracy is maintained. Then you need to be able to sign the worksheets that you are doing, and for small amounts, as we have said, make sure that you write in the correct units and in full and not abbreviations. And then for sensitive electronic balances, you always have to ensure you are tearing, and I think you have to be able to do this in the labs and make sure you understand what tearing is and how useful it is in ensuring accuracy in the measurements. So accurate weighing is important in as far as it helps to prevent dosage errors. And if we prevent dosage errors, then we are assuring that compounding will be proper, and we will provide the efficacy that we want to achieve in the management of different conditions. To continue with techniques for accurate weighing, what are the techniques? Accurate weighing involves setting balances, as we have said, just to re-emphasize that the balance should be firm, should not be moving as you are doing the weighing, and should be on a level surface. And so again, cleanliness is important. For the pans where you'll be putting the weights as well as the material you are weighing, and you centralize the pointer before use. Then handling, as we have mentioned, handling of material to avoid contamination, and then you need to know where to place the metal for balancing with the material that you are weighing. Cross-checking is crucial to ensure that the records are maintained accurately, and then cleanliness is important to ensure precision and avoid dosing errors. These measuring and weighing, they come with calculations. So in terms of liquid volumes and units, although the liquid is really outside the SI system, it is one of the most important units that we use in pharmacy, with each subunits, milliliters, deciliters, and microliters. Again, here we want to emphasize that still the smaller units like the micro have to be written in full to ensure that we don't or we do not confuse with the milli that is abbreviated as ml, so that we avoid dosing errors. And so graduated measures like the measuring cylinders that are graduated, the Conco flask, and all those that are graduated, meaning they have levels and indicated in terms of how much volume you will have reached. Those are very, very important, and you have to learn to be comfortable how to use them. And appropriate containers, like we are saying, have to be used to ensure precision in liquid measuring. Conversion between weights and units, volume units, this is crucial. A bit of calculations there. Pharmacy conversions frequently require translating weight into volume and volume into weight, like that. So 1 fluid ounce of water, for example, will have to be approximately 1 avioduple ounce. And the conversion tables between imperial and metric units, they are there to help you to just cross-check whether your calculations are accurate or are in line and proper. For small quantities, like we have said, conversion must be done carefully to avoid calculation errors. Some of the practice examples is converting grams to milligrams. Then it means we are moving from the larger unit to a smaller unit. So you have to multiply by the conversion constant, 1000. Milli means 1000. Converting 7894 milligrams into grams. Okay, again there's a conversion of 1000, but we are moving from smaller to large, so we divide by 1000. So for every small amount, converting 3.2 nanograms to milligrams, then by successful division by 1000, resulting into that. So here I think you have to note what the constant is that you need to divide or multiply with, depending on whether you are using milli, which means 1000, nano meaning relating to more digits there, or significant figures. And so that is very, very crucial. Otherwise, this is where we end. Look out for the next topic in key formulation skills.